Welcome to the Global Updates, bringing you the latest news from around the world. The earth shakes, Mount St. Helens stirs. The ground beneath my boots felt it. A tremor, then another. Not just a minor shudder, but something deeper. Mount St. Helens, a sleeping giant, was stirring. It was early May, 2025. The news crackled through radios first, then blazed across the internet. Reports from the Pacific Northwest Seismograph Network were coming in thick and fast. A swarm of small earthquakes, growing in intensity, clustered under the volcano's dome. The mountain that blew its top in 1980 was waking up, and the world held its breath. The question wasn't if it would erupt, but when and how violently. Whispers from below, unmistakable signs. Satellite imagery provided stark visual proof of the changes. Before and after shots showed the ground around Mount St. Helens visibly swelling. Thermal imaging revealed hotspots, areas where the heat from the rising magma was reaching closer to the surface. Gas emissions became a major focus. Scientists in protective gear ventured as close as they dared to collect samples. The concentration of sulfur dioxide, a key indicator of fresh magma near the surface, was spiking. This gas, with its pungent, rotten egg smell, is a direct messenger from the molten rock below. The air around the volcano was becoming a chemical soup, a warning of the potent forces at play. The ground uplift wasn't uniform. It was concentrated in specific areas, suggesting the shape and orientation of the magma body pushing from beneath. GPS stations recorded these movements with pinpoint accuracy. The data showed a relentless upward and outward push. It was as if the mountain was taking a deep breath, its chest expanding before a mighty roar. Nature's alarm bells. Wildlife on the move. The first to know, often before our fancy instruments, are the animals. They have an ancient, inbuilt sense for danger. Reports started trickling in from the forests surrounding Mount St. Helens. Elk herds, usually content in the lower valleys, were seen moving to higher ground, away from the volcano. Bears, normally solitary and elusive, were spotted more frequently, seemingly disoriented. This mass exodus was a primal alarm bell, a silent scream from the wild. Birds, too, changed their behavior. Species that typically nested in the dense forests on the volcano's flanks were observed abandoning their nests. Their calls seemed more frantic, their flight patterns erratic. It's a phenomenon seen before major natural upheavals, an instinctive flight response. The subtle tremors, the release of gases imperceptible to humans, were clearly disturbing the natural order. This wasn't just a few isolated incidents. It was a widespread behavioral shift across multiple species. The significance of these combined observations, fleeing wildlife and harmonic tremors, cannot be overstated. The harmonic tremors confirmed that the threat was real and dynamic. The Yellowstone connection, a disturbing theory. As Mount St. Helens continued its restless dance, a far more terrifying question began to surface. Could this awakening have implications for other, even larger volcanic systems? All eyes turned eastward, towards Yellowstone. Yellowstone isn't just any volcano, it's a supervolcano, one of the largest and most potentially devastating on the planet. The idea of a connection, however remote, sent shivers down the spines of even the most seasoned volcanologists. The hypothesis centers on the vast and complex plumbing system that underlies the western United States. Some geologists theorize that major volcanic systems might be interconnected at a deep crustal or even mantle level. Imagine a network of underground pipes, all part of a colossal geological engine. A significant pressure change or eruption in one part of the system could theoretically influence another. It's a terrifying thought. One giant waking another. The cascade dominoes. One eruption ignites another. The cascade effect theory takes this idea of interconnectedness a step further, particularly within a single volcanic chain like the Cascade Range. This majestic line of volcanoes includes not only Mount St. Helens, but also Mount Rainier, Mount Hood, and others. The theory proposes that a major eruption at one Cascade volcano could destabilize others in the chain. It's like a line of geological dominoes, where the fall of one can initiate a chain reaction. The stress changes in the Earth's crust, caused by one large eruption, could be enough to push a neighboring, already primed volcano over the edge. Imagine the immense forces unleashed during a large volcanic eruption. The ground shakes violently, vast quantities of rock are blasted away, and the pressure underground shifts dramatically. These changes don't just occur locally, they can propagate through the crust, altering stress fields over considerable distances. The implications of the cascade effect are profound. Guardians of the Gates, modern volcano watch. In the face of such colossal natural power, our best defense is knowledge. Modern volcano monitoring is a sophisticated, multifaceted operation. We're not just waiting for smoke signals anymore. We have an arsenal of high-tech tools that act as our eyes and ears. Seismometers form a dense network, detecting the faintest rumbles. These instruments are the frontline sentinels, providing the earliest warnings. GPS stations provide precise measurements of ground deformation. Satellite technology has revolutionized volcano monitoring. Satellites equipped with radar can map ground deformation with remarkable accuracy. When the giant roars, Yellowstone unleashed. Now let's confront the truly terrifying prospect, a full-scale eruption of the Yellowstone supervolcano. This isn't like Mount St. Helens, as devastating as that was. A Yellowstone eruption would be a civilization-altering event, a cataclysm on a scale humanity has never witnessed. The initial blast would be colossal, dwarfing any nuclear weapon ever detonated. It would excavate a caldera tens of miles across, spewing thousands of cubic kilometers of ash and rock into the atmosphere. The immediate vicinity, states like Wyoming, Montana, and Idaho, would be obliterated by pyroclastic flows. The ashfall would be the next devastating wave. A thick blanket, feet deep, would cover much of North America, collapsing buildings, choking machinery, and turning fertile farmland into a sterile desert. Darkness would envelop vast swaths of the continent for days, even weeks. Air travel would cease globally. Water supplies would be contaminated, power grids would fail, and agriculture would collapse across the continent. The sheer amount of sulfur dioxide and other aerosols injected high into the atmosphere would encircle the globe, reflecting sunlight back into space. This would trigger a volcanic winter, a significant drop in global temperatures lasting for years. The long-term consequences are almost too grim to fully comprehend. Bracing for impact. The need for readiness. Faced with the monumental threat of volcanic eruptions, especially one on the scale of Yellowstone, complacency is not an option. Preparedness is key, and it operates on multiple levels, from individual awareness to international cooperation. Scientific monitoring is the bedrock of this preparedness. Continued investment in research, technology, and the brave scientists who interpret the Earth's restless signals is absolutely non-negotiable. The earlier we can detect the signs of an impending eruption, the more time we have to react, to evacuate, and to mitigate the consequences. Every second gained is precious. Public education and awareness are also vital. People living in volcanically active regions need to understand the risks and know what to do if an eruption warning is issued. This means having emergency plans, go bags with essential supplies, and established evacuation routes. Communities need to conduct drills and ensure that communication systems are robust enough to handle a crisis. It's about fostering a culture of preparedness, not fear. Beyond immediate safety, we need to think about resilience. How can our infrastructure be made more robust to withstand the impacts of ashfall or seismic activity? For a Yellowstone-scale event, the challenge is global. Living with the beast. Constant vigilance. We live on a restless planet. Volcanoes are a testament to the immense heat and power beneath our feet. They create fertile soils and parts of our atmosphere. The challenge is to live alongside them with respect and caution. Mount St. Helens reminds us these beasts are never truly dormant. Constant vigilance is a societal imperative. Support institutions that monitor these threats and heed the warnings when they come. Don't become complacent during quiet periods. The threat from places like Mount St. Helens and Yellowstone will always be with us. Aftermath and recovery. When a volcano erupts, it leaves a path of destruction in its wake. Communities are displaced, landscapes are altered, and lives are forever changed. But amidst the rubble and ash, there is a story of resilience. Pause ones. Image, aerial view of a devastated town. The heartache of loss is met with the determination to rebuild. Neighbors come together to support one another, and the human spirit shines brightest in the darkest of times. Pause once. Video volunteers clearing debris. Volunteers work tirelessly, clearing debris and providing aid. Their efforts pave the way for recovery, turning despair into hope. Pause once. Video. Replanted forests. Nature too begins its healing process. Forests are replanted and wildlife slowly returns. Pause once. Image new homes being constructed. New homes rise from the ashes, and communities are rebuilt stronger and more resilient than before. Pause once. Video children playing in a park. Children play once again, a testament to the enduring spirit of humanity. Pause once. Video scientists monitoring volcano activity. Scientists continue their work, improving monitoring systems and seeking to understand these powerful forces better. Pause once. Image memorial plaque. We remember those lost but also celebrate the strength and unity that emerge in the face of adversity. Pause once. Video community gathering together, we rebuild, and together we move forward, ever vigilant and ever hopeful. Pause once. Image. Sunrise over a calm landscape. From the ashes, we rise, stronger and more united, ready to face whatever challenges may come. Lessons learned. Each volcanic eruption teaches us invaluable lessons. Image. Scientists analyzing data. Scientists meticulously analyze data, seeking patterns and insights that can help predict future events. Video educational seminar. Educational programs are developed to inform and prepare communities about the risks and safety measures. Pause once. Video emergency drills. Regular emergency drills ensure that everyone knows how to act swiftly and safely when disaster strikes. Image community meeting. Community meetings foster awareness and preparedness, making sure no one is left behind. Video engineers reinforcing buildings. Engineers design and reinforce structures to withstand the powerful forces of nature. Video. Children learning about volcanoes. Schools incorporate lessons about volcanoes into their curricula, instilling knowledge in the next generation. Pause once. Video international cooperation countries collaborate, sharing research and resources, recognizing that volcanic activity knows no borders. Pause once. Image. Advanced monitoring equipment. Advances in technology lead to better monitoring systems, providing early warnings and saving lives. Pause once. Video. Resilient infrastructure. Investments in resilient infrastructure minimize damage and accelerate recovery. Pause once. Image community. Resilient and prepared. Communities become more resilient and prepared, turning lessons learned into actions taken. Pause once. Video global solidarity. In the face of these formidable natural events, global solidarity and human ingenuity shine. Pause once. Image. Hopeful sunrise. With every lesson learned, we move closer to a safer and more informed future, ever ready to face the challenges ahead. Future preparedness. As we look to the future, preparation remains our strongest defense against volcanic threats. Pause once. Image. Scientists developing new models. Scientists continue to develop more accurate predictive models, enhancing our ability to foresee eruptions. Pause once. Video drones surveying volcanoes. Drones and other advanced technologies provide real-time data, offering unprecedented insights into volcanic activity. Pause once. Image satellite monitoring satellites keep a constant watch, monitoring changes and alerting authorities to potential dangers. Pause once. Video community education programs. Community education programs evolve, ensuring that everyone from children to the elderly knows how to respond effectively. Pause once. Video. International simulation exercises. International simulation exercises test and refine our global response strategies, fostering cooperation and readiness. Pause once. Video. New infrastructure projects. New infrastructure projects are designed with resilience in mind, ready to withstand the forces of nature. Pause 1s. Image emergency supply kits. Emergency supply kits become a common household item, ensuring that essentials are always within reach. Pause 1s. Video. Scientists collaborating globally. Scientists around the world collaborate, sharing data and breakthroughs, pushing the boundaries of what we know. Pause 1s. Video. Real-time alert systems. Real-time alert systems become more sophisticated, providing critical information at the earliest signs of trouble. Pause 1s. Video volunteers training for emergencies. Volunteer groups train rigorously, ready to assist at a moment's notice. Pause 1s. Image hopeful community. With each step forward, we build a future where preparedness and resilience are at the forefront, ensuring that we are always ready for what lies ahead. Pause 1s. Video. United efforts. Together, through united efforts, we can face any volcanic threat with confidence and hope.